All right, you guys, we are in similarity and similarity transformation still. This is slide number 10. And I'm going to move on into where my GeoGebra activity is. All right, let's see what we got here. Now, it looks like we got two different figures. Being that we're talking about similar triangles, makes me wonder if they are the exact same ratio. I don't know. I can't really just tell. It's kind of looks like it's been rotated or something. I'm not sure. All right, so the question number 1 says use the distance formula to calculate the ratio of a side length on triangle DEF to the corresponding side length on ABC. Show your work, then confirm your calculations using GeoGebra. All right, so we got to calculate the ratio. All right, so I need to find the distance of one side of this triangle, compare it to the same position side of this ABC triangle, and then find the ratio. Well, when I find the ratio, that's going to be the scale factor. All right, let's see what I got here. So I guess I'll do DE, and that corresponds to AB. So I'm going to do AB and DE. AB and DE, they're in the same position. Even though it's been like rotated or something like that, AB and DE are in the same position. Okay, so let's see. I want to find AB. All right, here. So I need to get what A is, I guess, huh? All right, A is 1, 1. B is 2, 3. A is 1, 1. B is 2, 3. And I need to do the distance formula. Okay, well, the distance formula is right up here for you. You're going to take your x2 and minus x1. I'm trying to figure out how I'm going to do this, to be honest with you. I probably need to I can use my equation editor. So it's going to be a big old square root. Move this down so we can see what we're doing. All right, so your x2 is 2. All right, x1 in your problem is the 1. And don't forget your square. Plus, whoop, go back. I need that plus to go with it. Plus, there we go. All right, and then y2 is 3, and then y1 is 1, so we 3 minus 1. And squared. All right. Let's see here. All right, so 2 minus 1 is 1. Squared is 1. 3 minus 1 is 2. 2 squared is 4. So I am looking at the square root of 5. Let's see, what is the square root of 5? So 5 square root. All right, it's about 2.24. 2.24. All right, so 2.24. All right, now that was AB. So I'm going to click OK. Whoa, put it in the wrong position. That just figures. Let me see if I can move that down. I need to move it down. Okay. All right, let me come back here and do that. There we go. No. There we go. Okay. Whew. All right, so there's AB. All right, now I need to find what's in the same position as AB. Well, if AB are my first 2 letters, then DE are going to match up to it. They're also my first 2 letters. So I'm going to come over here to D, which is 5, 1. And E, looks like it was a decimal. 8, negative 0.5. 8, negative 0.5. All right, so I need to do the distance formula again, except with my new numbers. So I'll come back to my equation editor. Make this a little bit smaller. Okay, so let's see. x2 minus x1 squared plus, all right, y2 minus y1, so it's going to be negative 0.5 minus 1 squared. All right, whoop, go back. All right, so 8 minus 5 is a 3. 3 squared is 9. And negative 0.5 minus 1 is a negative 1 and a half. Square that. Ooh, I'm not sure what that one is. Probably a 2.25, something like that. All right, 0.5 negative minus 1. Square that. So where's my squared? Right there. Hey, I was right, 2.25. 2.25. Go me. 2.25. All right, so I'm going to add those together, and I get 11.25. All right, now I need to find the square root of 11.25. So 11.25, that's going to be about 3.35. I got it over here, 3.35. 3.35. All right, let me put, okay, so I can put that into my problem. All right, so it says, got to find the distances to calculate the ratio of the side length to the corresponding side length. Show your work, then confirm your calculations using GeoGebra. Well, of course, that's what it says. So I'm going to come up here to my angle icon, select distance or length. So click on AB, and I got 2.24. Click on ED, and I got 3.35. Look at that, on the money. All right, so let's see. I'm going to hit submit. All right, there I go. Oh, okay, they wanted me to calculate the ratio. So I'm sorry, I thought that was going to come up. I just assumed it was. Divide those to get what your scale factor is. So if I take 3.35 and I divide by 2.24, then I end up with the scale factor, and they say the scale factor is 1.5. So 1.5 means that this green figure is 1.5 times the size as the blue figure. So it increases in size from blue to green. All right, I didn't realize they wanted that. I apologize. Question number 2. Find one or more sequences of rigid motions and dilations that will map ABC to DEF. Often there is more than one sequence that will map a preimage to a similar image. The table below provides spaces for 2 different sequences. Begin by setting the scale factor of each dilation n equal to the ratio you computed in question 1. All right, so that means they want us to dilate it first as a 1.5. Then find the rigid transformations needed to complete the mapping. Perform the transformation in GeoGebra. Okay. All right, so the first thing they want us to do is do a scale factor of 1.5 to make it dilate. And again, I'm going from ABC to DEF. Let me erase this. So I'm going from this blue figure to this green figure. And they want me to do a dilation first. Oh, I need a point of dilation. So the easiest probably is to understand origin. All right, so put a dot at your origin. Come over here and click on dilate from point. So I'm going to click on my blue figure, which highlights the whole thing, and also my point. Now I'm going to put in a scale factor of 1.5 because it gets to be 1.5 times the size. All right, let me move this so we can see it a little bit. All right, so it appears that this blue figure is now the same size as this green figure. Okay, so looks like it might be a rotation. I said that earlier. I need this C right here to swing down. Not going to be a 180 because 180 will put it like way on over here. I'm thinking maybe 90. Maybe a 90 degree. Okay. So let's see. And I need to go clockwise because I need to go to the right. So I'm going to try it. I've already got an angle of rotation. So let's see what's going to work out. So I'm going to rotate around a point. Click this big object, the one I dilated. And I dotted the origin. And I'm going to put 90 degrees. And I want it to go this way, which is clockwise. So I'm going to click on clockwise. Hey, not bad. Look. I am in the general vicinity. So I'm definitely in the same type of position here. I just need to kind of slide this sucker over, it looks like. And the question is how much do I slide it over? And this might be a little difficult because this one's right in the middle of its square. This one's not. So I might have to do a little guesswork here. First off, even C to F doesn't look like it's nice and neat. B to E doesn't look like it's nice and neat. Gosh, looks like I'm going to go to the right one and a part. And it's not going to be a whole part. Maybe 1.5 to the right. I don't know. Oh, you know what? I forgot to do. Let me do a rotation. Rotation 90. And I did clockwise. Okay. So I'm going to kind of play around with this. I know it's going to be a translate. So I'm going to come over here to translate by vector. I'm going to click on this object. I'm going to go over 1, and gosh, maybe a 3/4 of 1. So I'm going to kind of see. So I'm going to click here. Click where I think it's going to be. All right, so it looks like, yeah, it looks like it's maybe 1 3/4. Now I'd have to move it up. So I need to do a vector. It looks like it's going to be maybe a 1 3/4 again. So let me see. I'm about right there. Move it. Oh, it's not on translate by vector. Let me do this again. Translate by vector. This one. And let's see. Looks like it's here all the way up to about halfway. Oh, wow. Yeah, pretty close. So it looks like it's right 1 3/4, up 1 3/4. That's just a little human error that it's not sitting exactly on it. Yeah, still 1 3/4 and 1 3/4. All right, so it's going to translate right 1 3/4 and translate up 1 3/4. All right, so there's my first one. They want me to do a different sequence, but they still want me to do the dilation first. Okay, well, let me erase all this. Get back to my original. Yeah, I can probably keep this one. Let me go back. So there's my dilation. I can keep that one because they wanted me to start out with that one anyway. N equals 1.5. So I'm not going to do a rotation. Well, let's see. What can I do? Oh, you know what? A rotation of 90 degrees clockwise is the same thing as a rotation 270 degrees counterclockwise. Ha! I want to beat them at their own game. Watch this. So come over here to rotate around point. Click on the dilated one and the point of rotation. All right, I'm not going to go 90 degrees clockwise. I want to do 270 counterclockwise. And watch, I'll end up in the same position. Bam, look at that. So the first time I went to the right, this time 270 all the way to the left. And I ended up in the same position. So I'm beating them at their own game. But why not? When I know my math, they're the same. Why not beat them at their own game? So rotation, 270 degrees, counterclockwise. They're the same thing, you guys, which means that I can translate right 1.75 again and translate up 1.75. I love it. Beat them at their own game, you guys. They're the same thing. Hit submit. All right, so they did all kinds of things. Now, wait a second. Why do they tell me to dilate first if they didn't do that? Equal the ratio in question 1. begin by setting the scale factor. Well, they tell me to begin by doing the scale factor 1, and they don't even begin by doing the scale factor 1. Whatever. I rock. Figures. Okay, so we got question 1 and 2 done. Question 3. Okay, you just completed a similarity transformation to show that ABC is similar to DEF. Let's see how the corresponding angles relate between the two similar triangles. Find the measures of angles ABC and DEF and record their values. Okay, that's an easy one. So let me get back to my original figures, you guys. All right. So they want me to find the measure of angles. All right, so to find angle measures, we need to come back over here. Click on angle. All right, hang on a second. All right, you guys, so they want angle A. So let me come back over here. Go to your angle icon and select angle. Now remember, you got to go in a right circular motion. All right, so you got to click on C first, then A, then B. So it looks like angle A is 26.57. All right, let's find D. All right, so let me move this because we got to click in a clockwise motion. So come down angle. Now to get D, you got to click on FDE, 26.57. Looks like my angles are going to be the same. Well, let's find angle B. Now clockwise motion, you guys, so got to click on A, B, C. I got 135 degrees. And angle E, so I'm going to click on D, E, F, 135 degrees. Okay, angle C. Clockwise motion, so B, C, A, 18.43. I got $5. It says F is also the same. So click on E, F, D, 18.43. You took that bet. Give me my $5. All right. So we got that done. So hit submit. Question number 4. Compare the corresponding angles of the triangles just made. In general, what are your observations suggest about the angle measures in the two similar triangles? Well, after it was dilated, there was no change in the angle measures. After dilation, there was no change in the angle measures. Use the definition of similarity transformations to explain the relationship between the corresponding angle measures. Similarity transformations to explain the relationship between the corresponding angle measures. Well, the definition of similarity transformations is the angles will remain the same. The sides will be proportional. So the angles will be congruent. I'm not really sure what they're asking, but that's what they are. Let me hit submit. Equal. All right, so they're equal. I said congruent. And similar. Map to the other using dilation sequence. Okay. Both dilation angle measurements. Okay, so they're going to just be congruent. They're going to preserve angle measurements. And I said there was no change. Okay, so I looked in that just a little bit too much. All right, question number 5. Use the distance formula to calculate the length of each line segment of A, B, C, D, E, F. You do this for a line segment in question 1. Determine the ratio. This is a scale factor in. Then verify that they're going to be equal to each other. Okay. Well, DE. Come back to distance. What did we say DE? Was it 3.35? Yeah, 3.35. Remember that one. 3.35. And I know we found AB was, I think it was 2. What was it? 2.24? Yeah, 2.24. All right, so let's find the rest of them. So we need to find EF, 4.74, BC, ABC, 3.16. All right. FE, I'm sorry, my bad. DF, 7.5. And last but not least, CA, C to A, 5. Okay. Well, we already know, the scale factor is going to be 1.5 because we found that in the first one. When you divide the ratios, they equal 1.5. For you visual people, if you're trying to figure out what I'm talking about, 3.35 right here, divide by 2.24 is 1.5. So if I take 4.74 and divide by 3.16, I'm going to get roughly 1.5. 7.5 divided by 5, 1.5. You can't do a scale factor of one side and it not be the same for the other ones. Okay, so let's see. So roughly, scale factor in. Alright, so if you're multiplying the scale factor 2.24 times 1.25, well, that's going to get 3.35. If you multiply the scale factor 1.5 times BC, which is 3.16, it's going to go right back to here, 4.74. If you're going to multiply the scale factor 1.5 times CA, which is 5, well, 5 times 1.5 is 7.5. We've done this several times. You should know that by now. They're definitely bringing it on together. All right, question 6. Okay, last one. In general, what do your observations suggest about the corresponding sides of two similar triangles? Well, the ratios are going to be the same, and it's also going to determine the scale factor. The ratios will be the same, which is the scale factor. All right, so self-eval is 5. Yeah, we've been doing this for a while now. Same thing over and over and over again. So there you go. Hit submit, and I'm going to hit submit. All right, this looks like this slide 10 to 14, and this may be the last one for this lesson.